Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be talking about kernel modules specific to Linux. And we'll talk a little bit about why they grew out of stuff and what was used before and, yeah, all that good stuff. So let's get started right after this. We're definitely going to talk about the kernel modules today. And so what we mean by kernel modules is that they are things that you can plug in. And we're going to talk about some of those today. But so the things that we're going to cover in this one are, why are there modules? What is the loadable kernel module, or LKMS? What commands are used to manage and status those modules? And I'll be using some examples, but I don't want you to walk away thinking that modules are just for device support. They're not. In the old days, the computers had no hardware support directly. They had electrical support, and they had, some very primitive wiring that allowed me to address memory. Because like on this is the Apple, I think this is an Apple IIe, it looks like. And the Apple IIe had addressable I/O, so it used memory to address the access to the card. And it had, I think, 7 slots, and you could plug in the cards to it, but it's been a while since I've opened one. But on those, in order for those cards to work, each one of them had to have erasable programmable read-only memory, or EEPROM. And EEPROMs were used to contain the program that the system would execute in order to have that board do a function, to do a thing. And so if you did not have a board built specifically for the Apple IIe, it wouldn't work. It wouldn't work. So if it was written for an IBM PC, or if that, whatever, you not only had electrical differences, but you also had programmatic differences. So your board had to be developed specifically for your machine. And that was fine, but that means that a manufacturer that was building cards had no standard to follow, right? Because everybody did something different. There was the S-bus machines, like the ones built from Cremico, and there was several other ones, but those had their own. They ran CPM. They had their own memory, their own way of handling drivers. Apple had their way of handling drivers. The Atari and the PET had their way of handling drivers. TRS-80 had their way of handling, and nobody agreed on anything. So, it was kind of a mess. In the newer old days, I'm going past DOS because somebody gave me a bunch of crap about it last time. So, all right, fine. I won't talk about DOS. We'll talk about Windows. So Windows 2.x and 3.x used something called the Vxd Driver, which was the virtual X driver. And basically that was because of the way the name was written out to disk. And Windows communicated to those usually by interrupts and I/O address ranges. So, all of them basically still use the interrupt model and the I/O address range model, but you don't see that anymore. It was a real chore back then because you had to avoid collisions between cards, both from the standpoint of which interrupt it was using and which I/O address it was using. There was no guarantee that a card wouldn't step on another card that was plugged into your machine. Windows 98 and 2000 introduced the Windows driver model, which is still used today. And Windows 10 and 11, it's been updated. There's a bunch of new things that are in there. So I don't want you to think it's the original one. It isn't. Windows NT had its own called the Windows NT driver model. And there's still more. But wait, there's more. So some of the ones that other ones that Microsoft have is the Windows driver framework. There's also the kernel mode driver component. There's also device object and device stacks. The great thing about standards is that there's just so many to choose from. So yeah, we were looking to avoid all that. There's really two choices, right? There's three. there's three choices in handling device support. So you can either pile it all into memory, which means that your kernel gets bigger and bigger and bigger the more types of products it tries to support. You can follow the Windows model, which is, I'm not going to handle anything. I'm just going to let you write it, the person that's developing the hardware for the platform. If you want to sell it, you got to sell it with a driver, because I'm not doing nothing to help you other than give you a standard to follow to write your device drivers. Or you can do what Linux did, which is I'll create a basic set of drivers that I'll install into the kernel, and those will get loaded at the time that I boot up the machine. And that is normally called a base kernel or a basic kernel. There's also a minimal kernel, which basically strips it down even more. And then if you want to add on functionality, you have to add that support in yourself. But there's also, so the device support can also be configured by a loadable kernel modules, or LKMS. The reason for the loadable kernel modules came about because there was it usually takes 2.5 months or so before a new kernel is developed. And so, yeah, it could be a long delay between a new machine comes out and you're being able to use it with a Linux kernel. So the LKMS came out in order to provide a means to load modules into memory that could then be used by the operating system. So there was standard ways that the kernel would communicate with modules in order to allow that support to happen. So Linux, when it boots up initially, the basic set of device support is provided in the initial RAM drive that it builds on boot. And then after that, it has just enough intelligence beyond the basic set to start probing the system and looking for drivers, and it may result in loading LKMS modules in order to support those drivers. So yeah, it loads whatever needed device modules as they're discovered. So yep. So the device module is just one type of kernel module. I don't want you to walk away thinking, oh, this is just about devices. No, there's more to it. There's just about any kind of functionality that you want to add onto the kernel, whether that be a new VPN or a new cryptographic algorithm, or maybe there's something, a new method of doing encoding for your videos or audios. Those can also be added into the loadable module. There's also things like KVM, which is your virtualization. Those get loaded in as modules as well. There's some modules that are subsets of KVM, like one for Intel, one for ARM. So yeah, there's all kinds of different things that are used, but basically think of a module as a way to extend the functionality of the system. That's the best way to look at it. It's not just device drivers. I'm just using that as an example. So today we're going to look at 3 different commands that are used to both gather information about modules on your system, as well as to look at like lsmod gives you a list of all the modules that are currently loaded. Mod info allows you to gather additional information about modules that are installed, or are resident on your disk and not loaded. So you can see all of them that comes with your kernel. And you can also probe the ones that are built in. And we can look at that. And then there's the mod probe, which is used to install new modules or remove modules. It also has a dry run feature, which allows you to go through and see what the impact is going to be to your system. It'll show you if you load this module, you have these dependencies that are going to come along with it. And yes, modules have dependencies just like packages do. So yeah, it's possible that you could have a whole string of dependencies that are coming with that module that you want to install. Okay, so what I'm going to do today is I'm going to go through a couple of the commands with you for modules. The first one is lsmod, and lsmod, all it does is it formats what's in the file /proc/modules. So if you saw my internals on proc, you know what those are for. So let's just look at what proc modules might look like if I just list it by itself. So yeah, you can see that it starts to list down through here. Here's the module name. There's some information about it. There's its device and all that kind of stuff. Yeah, but it's not very nicely formatted. So if I do ls mod, I'll get it exactly in the same order that appears in proc module. So there's my command, and there's the start of my command, and then here is the information. This time it's all nicely. There's the size it's used, and then yeah, and you can kind of see all of the different things that have to do with it, like dependencies and all that kind of stuff. But the problem I always have with this listing is, as you notice, it's not in alphabetical order. So if you're looking to see if a certain module loaded, you can't find it. Let's do a sort and then a more. There we go. Now I can page through it. And this time I have all of it alphabetized, so I can find the particular one I'm looking for. So yeah, that's lsmod, and it's just a command to list the ones that are currently loaded in your system. So what if I'm interested in a particular module? So let's say that I know I want to put up WireGuard at some point, right? So let's look for the WireGuard module. Okay, and we get that back, and we get some information about its version. Probably going to have to scroll up here because the first thing it should give you is its actual file name. So this is the location of the actual module itself. And you'll notice that it is taking, that should be my current uname -r. So let's see if it is. 22.1 E9, 22.1 EL9. Yep. So, and then under kernel drivers net WireGuard, WireGuard.ko.xc, so it's compressed. And it has an alias. It has another alias, and then it is version 1. Talks about who made it, and it's GPL version 2, and it's for RHEL version 9.0. So yeah, it gives you quite a bit of information about it. Yeah, it also has the signer and the key and all that kind of good stuff. So yeah, so that's what mod info does, is it allows you, if you know the name of the module, like let's go back to our ls mod example. Let's say we're looking for, yeah, let's see if we can find something on KBM Intel. Let's see. So let's do that one. Okay. Oh, this time it gives me some parameters. So, all right, let's scroll too far. Let's go back down here. Okay, so there's my command. There's the library name for where that particular KVM module exists. The version of the operating system it goes with. Its alias, which it depends on KVM. Okay. So yes, modules do have dependencies, and so in order for you to load this module, this one has to be present. So when you do well, we'll get to that, but when you do start loading modules, it will attempt to load the dependencies along with it. And then these are parameters that you can pass when you're adding a particular module to the system. So if you know what parameters you need to modify, maybe you're loading a device driver and you need to pass parameters with it, this will give you an idea of which ones are available to you. But I would suggest you look at whatever device driver you have, make sure you understand what these are doing. Because if you don't understand what they're doing, it's a good way to knock your system down. So, and we don't want to do that. What if I want to look in this directory on its own? So how do I do that? So I would do, first thing, get the name of my kernel, right? And then I would do an ls on lib modules, and then $, I can pass the output of the command to the ls. So the output of uname-r will be inserted here as the directory. So if you're not familiar with that on Linux, there you go. Now, and you can add on to that. So as you'll see, I have a kernel directory here. I can look at that as well. And I can see that there's some drivers under there. And if you noticed, this one is under, okay, so it passes this. It goes to kernel arch x86, then KVM. So let's see if we can follow that through. And there's KVM right there. And there are my drivers. There's KVM Intel, ko.xc. So yeah, you can, if you don't know the name of it, you can find it. Yeah, you can find it. So what else do we have? Well, you'll notice that there's some entries here for modules like built-in. So what is that? So these, if I did, here, let me show you here. So if I did a mod info, and I'm interested in finding out one of the one of the USB ones. Let's see. Maybe we should just do a more on that and just look. Let me just do this. Let's do a more on it. I think those are text. Some of them are not, like the .bin right here, that's binary. So yeah. So yeah, there's my stuff here. So I can look up. Some of these are built into the kernel, and so you will not see them. They won't be in these directories because they have been compiled into the kernel, which you can do. So modules can either be external to the kernel or they can be compiled in. And the inbuilt ones are recorded here. So these are your basic set of modules that get loaded at the time your system boots up. So yeah, they'll contain some drivers, and those drivers that are in the built-ins are usually the ones that would be common to most systems, right? Does that mean that all of these may be in use? No. But it means that the kernel has them loaded. So one of the ones that I was interested in is this one right here. So if I were to look for that under, let's see if we can just get there. Let me do a print working directory. Let me just do a CD. We want to go to kernel, drivers, USB. All right, let's see if we actually have a kernel, excuse me, a module there. All right, so, and it should be in host. Do we have a host? No, we don't have a host. No such file or directory. So I could do it should come back and say, well, it found it in the kernel, I guess. What about loading modules? What about, okay, let's take a WireGuard, for example. So we know that we've done the mod info on WireGuard, and we see that there is a kernel driver for this one, and it is not married to the kernel. And you can tell because it's got a fully qualified path name, right? So you know that is actually sitting out on disk. So I want to load WireGuard so that we can get some. So the first thing we want to do is we want to retrieve a mod info for the module I want to load. Now, as it turns out, WireGuard actually will load all by itself if I enter the IP link and add the link for the device type WireGuard. So yeah, it'll automatically create that. But let's say hypothetically that we're interested in that. So I've done the mod info about the kernel I want to load. And there should be some dependencies, and there is. Look at all those. There's a bunch of dependencies here. And this will try, if I load the WireGuard, it'll try to load all those dependencies with it. The thing we want to do here is we want to do a dry run. And to do that, I would do a sudo mod probe. And then N is for dry run. I want all of them, and I need to see verbose. And then we'll type in WireGuard. And so it's just going to show me what it would have done had I left the minus N off. So it says remember the dependencies we had were lib curves and curve and UDP, IPv6. So some of these might be dependencies of dependencies. So yeah. So there's one of the live Blake ones, and there's the finally at the end it does the WireGuard. But like I said, there's an easier way to do this, and that for WireGuard anyway is link add wg0 type WireGuard, and then I should see the WireGuard device type, and then I can do an ls mod. We'll do a sort. And then there's WireGuard there, and I can see that. So, however, I think that's right. No, delete. Yeah. Oops. So now my IP address is gone, but one thing you'll notice though, it did not remove WireGuard. So I can remove that if I want to. So yeah. And you can look at the man probe for that. There should be a -r lowercase right here, remove. So if I do a, now let's do this time. Let's do the dry run again. We'll do a -rvm and we'll do a WireGuard. We just want to make sure that okay. So it's just going to remove WireGuard. We hope. But it went ahead and it lied. It went ahead and did the RM on WireGuard, curve, and all those things. So yeah, it went ahead and removed them anyway. So yeah, so basically that's how you manage modules. All right, let's go back and talk about this whole thing again. That's all I had today about modules. I hope you enjoyed this look at them. It's, again, I'm trying to expose you to some of the internals without trying to get so deep that I glaze you over. But just explain, here's what you need to do. Here's, if you're having trouble with a device, here's some tools that you can use to help you diagnose it. And yeah, hope you enjoyed it. If you did, please like and subscribe. Hope to see you again real soon, and bye for now.